Hello, everyone. Welcome back to the Microcontroller Application Technology course. Today, we will learn about the calculation and display of seconds. By using an 8-digit display to show an initial time value, we can begin to design the specific functions of an electronic clock. The primary use of a clock is to measure and indicate time. Today, we will design and implement the function of calculating and displaying second values. First, let's look at the display effect of second values in the simulation. How do we design and implement the function of displaying and changing second values? The hardware circuit part is the same as in the last lesson. Our focus this time is on the programming and design of the software. Let's recall what we learned in lesson 4.4. The task of displaying numbers 0 to 9 in rotation every second using a timer. In that lesson, we learned how to use a timer or counter. For this design, we need to generate a signal for seconds, which will also involve using a timer or counter. Suppose the initial time of the designed clock is 2049. The main function we need to design first should implement the display feature. From left to right, select the displays one by one to display different numbers, and continue the cycle indefinitely. Initialize the timer T0 specifically in an initialization function. The role of the delay function here is to implement the delay between switching displays on every 2 digits of the digital tube. The interrupt function is most important, as it needs to complete the +1 function for seconds and the carry calculation. Let's check the program in detail. This is a one-dimensional array containing the segment codes corresponding to digits 0 to 9, a dash, and an off state, which are used by looking up the table. For example, when you need to turn off the display, the corresponding segment code is 0 times 00, and the instruction P0 equals ensure 11 can send the off code to port P0. In programming, we also need to define 4 variables. Secnum for storing the count of 100 occurrences when the timer times 10 milliseconds. Secnum1 for holding the current second value. Sec for holding the high order digit of seconds, and secal for holding the low order digit of seconds. We start counting from 00, so both the high order and low order initial values are set to 0. The program requires the delay function and the initialization of the timer/counter T0, so we modularize these functional statements into a delay function delay and an interrupt initialization function init, facilitating their later use in the main function. This is also an important way of thinking in C language program design. Let's add a piece of knowledge here, the hashtag define macro definition, which appears in the second line of the program. Hashtag define is a preprocessor directive in C language. When editing a C source program, you can directly use the defined identifiers. During compilation, the compiler will replace the occurrences of the symbolic constant in the program. The form of definition is as follows. Take hashtag define yucker and sign char in this task as an example. In the subsequent program, wherever unsigned char is used, it can be controlled by yucker. This is the main function, where the program begins execution. Since the timing function requires the use of timer T0 for timing, the initialization function must first be called to initialize T0. All statements in the main function are contained within a while loop, and all statements within the structure are executed over and over again. Starting here, every 3 instructions form a group, completing the display function for one display. It is particularly important to note the 2 digits on the far right. They display the current high order and low order values of seconds. When displaying, since the numbers change, we store the 2 numbers in the variables sec and sacal, respectively. When using the table lookup instruction, the number in the brackets is represented by the variable name. For example, when the current high-order value of seconds, sec, equals 5, we use the instruction p0 equals ceinture, sec, which is equivalent to using p0 equals ceinture, 5, to look up the segment code for 5 and display the number 5. This is the T0 initialization function, which first specifies that T0 operates in mode 1. This is for calculating the initial value of the timer for T0 to time 10 milliseconds. This enables the overall interrupt and T0 interrupt, turning on the T0 interrupt. This is the delay function, used to implement the delay between switching displays on every 2 displays. This is the T0 interrupt function, which triggers an interrupt every 10 milliseconds. Upon entering the interrupt, the timer's initial value must be reset. We increment the counter secnum by 1 and then check if the interrupt has occurred 100 times. If it hasn't reached 100 times, it means the timing is not yet 1 second, so we skip the next 6 instructions. If it has reached 100 times, indicating that 1 second has passed, we execute the 6 instructions within the if statement. First, the variable counter secnum needs to be reset to 0, then the second counter secnum 1 is incremented by 1, and we check whether it has reached 60. If it has, we need to carry over to the minute value and reset the second value to 0. We will learn about carryover in the next lesson. Finally, regardless of whether there is a carryover, we need to split the high and low values of the seconds into 2 separate digits for display, corresponding to these 2 instructions. Let's look at the simulation results together. After the simulation starts, the second value begins from 00, and every second it increases by 1, from 01, 02, 03 to 59, then resets to 00. This achieves the calculation and display function of the time seconds. In today's lesson, you should have mastered the display and change of the electronic clock's second value, understood the use of #define macro definition, updated the thinking of modular programming in a program, and consolidated the design of multiple displays. Finally, please reflect on this lesson and complete the following exercises. In the next lesson, we will continue to improve the functions of the electronic clock. See you!